Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have with me Idan Gazit. Idan is a senior director of research at GitHub Next, a research organization inside GitHub with the ambitious task of exploring strategic technologies under the Office of the CEO. He next created Copilot and incubated many other long bet projects like GitHub's new code search capabilities. Idan was a part of that. Before that, he was a principal engineer for data user experience at Heroku, where he was responsible for the interfaces of Heroku's data products. And he's now spending his time thinking about how ML products could be incorporated into the future of GitHub's platforms. And that's hopefully some of what we're going to get into. So Idan, thank you so much for taking the time today.
Thank you so much for having me.
Awesome. So let's dive into it. It sounds like you have a pretty unique job that maybe a lot of people would be jealous of, that involves quite a bit of freedom to choose what to work on. So how do you choose what to research?
That's a great question. I would love to say that it's some super scientific process. But I think it has a lot more to do with fucking around and finding out. But in a sort of like directed fashion. GitHub Next is the long bets team of GitHub. So our job is to do the things that maybe the rest of the business wouldn't feel comfortable doing, things that are too risky, things that might be worthwhile, but a reasonable engineering org is going to look at and say, no, I have like lower hanging fruit to pick, which is very sensible. But if you do that over and over again for enough time, eventually you end up in a position, innovator's dilemma, where people who are taking the risky bets are going to find something that's fundamentally better. So it's kind of our job to be the in-house team that seeks risk instead of avoids risk. And figuring out what to work on is generally a process of we try things. We have sort of like an exploration season. And we're a very small team, so it's 20 people end to end, including the managers, who are all makers, and everybody's relatively on the experienced end of the scale. We don't have like our most junior member is a senior, and so there's sort of a lot of trust. Everybody sort of goes out and tries things, and it sounds like from zero, but it isn't really, because almost always in the previous cycle there were interesting paths that we were like, okay, we're not going to do this now because we're busy, focusing on this, but later we should come back and check this out. And so there's usually always sort of repeating, sort of like ideas that sort of come out from the previous cycle. So we have sort of like permanent hack week for like 2 months where we're trying things out, and our goal is to sort of persuade one another what's interesting. And it has a lot of the vibe of like a jazz band. Everybody's like playing and improvising and trying stuff out, and then somebody plays something that's like really good, and then everybody's just like, whoa, go play that again, that was good. It sounds messy, but in practice what's emerged now, I've seen this cycle over the last 4 years happen over and over again. It always emerges that where we find a theme that, like, it's like they were 3 different sort of like prototypes that people were sort of trying out, and then when we actually look at them together, we're like, wait a minute, it turns out that we're taking bites out of the same apple from different angles, and actually nice. Here's the underlying theme that, like, all these explorations sort of that, and then from that we work backwards and say, okay, like, if we wanted to really explore this theme, now that we understand the theme, is one of the existing like prototypes the one that we want to like double down on, or is it actually something slightly different, or it's like a mashup of like some of the different prototypes? So the cycle that we go through is like, it's exploration, go wide, we try like a bunch of things, and then picking and going narrow, but very frequently it's informed by the sort of choice of theme. And then we're doubling down, we're making on that particular thing with the goal of producing a prototype that needs to persuade the rest of the business that something is worth doing. Like that's the thing that we're measured on. That's the thing that we need to produce at the end is not just like, I'm a philosopher bearing a Google Doc and this is what we believe should happen. No, we have to persuade engineering, which is risk averse, that this is a risk worth taking. And so if we're saying like, we believe that there's a good experience for X, we need to show up with that experience or some small version of it to really prove the point. So that's our rough cycle. It sounds very chaotic, and it definitely rests on top of this foundation of having people that are very experienced, that, we can trust that they're not going to just wander off for 6 months and do nothing. But within those guidelines, picking sort of like narrowing in on the theme and then narrowing in on what to build in order to best do a thing for that theme.
Interesting.
And it works.
Yeah, it looks like it works. I think that there's a lot of corollaries or equivalents for what you're saying in just entrepreneurship and early stage startups. One of the sentences that we like quoting at DagsHub is a good entrepreneur needs to run towards danger. So it sounds like that's very similar to what you're describing. You look for the place that everyone is running away from and go towards that to see if there's anything interesting going on there. There's also the interesting point that you mentioned in the end where you're saying basically that the external validation that we need to provide to the organization is we need to go to someone who's not as risk-taking as we are and prove to them that our efforts have sort of crossed the chasm into the realm that they can take on, which is really nice. I can see a lot of equivalents there to maybe like fundraising or selling the product to non-early adopters. And one thing I'm specifically curious about is how much of the sort of volume of work in GitHub Next is ML focused versus working on other stuff?
That's a tricky question because ML is not AI. I'm not exactly gonna draw. There's some amount of ML focused work. I mean, for sure, we mess around with the open models, but prompt crafting, is that ML? I'd argue maybe no. And that's quite a lot of what we do. It's the work we do sits at sort of this intersection of sort of practical engineering and sort of lower level raw nitty gritty. Yeah, we do some ML stuff. We do some of our own model training. A lot of what we do is AI focused, but even if you look at Copilot itself, which is obviously this is a major AI product, and you'd think that there's a bunch of ML work behind it. A lot of the work that went into that was this very sort of unsexy work that doesn't look at all like AI or ML work. It's building an evaluation harness. It is, setting up sort of tracking for we roll something out. Is it doing better? It's prompt crafting and trying out different strategies for how we do that. It's even, sort of user experience things okay, we have ghost text. We need to track how often people accept suggestions, and then how much of the suggestion do they retain after what amount of time, figuring out ways to actually understand how people are using it to understand whether or not it's performing better or worse, because the models are not deterministic. It's not like we can just have a test suite and it'll be you are 0.4% better after this week of work, No, we have to deploy it and look at how it's performing. And even that's really hard to know. So it's my answer is twofold. It's there's a lot of ML work and there's also no ML work. It's the a lot part can seem sort of unrelated. But I'd say going forward, there's more and more as we sort of move away from in the beginning, it was okay, how are we going to apply the models? Now everybody has the models. They have the same models we do, right? We sit on top of OpenAI, just like everybody else. Maybe we have early access for sure. Mm-hmm. But at the end of the day, we're not going to succeed more than anybody else in the marketplace because our model is better, because we're using the same models. So we have to work hard to figure out how to take and apply this technology. And it's a leaky abstraction, like, seeing through, like, the models are a black box, how are they trained? Sure, we can fine tune, but like, like how is it going to respond to like this strategy, that strategy of like what we show, and then building things to go out and collect the data that we need in order to craft like the right prompts to reliably return useful things. That requires a certain amount of insight into how models work. So it's a lot, but maybe it's none. I don't know. It's a little hard to say.
It's a very sort of a deep philosophical answer.
Yeah.
But I think it makes sense in the sense that I think this also relates to some of the directions that we're seeing, which is that on one hand, you need to know a lot less about ML to use it. But on the other hand, if you lose sight of the fundamentals, which is understanding data, understanding how the data is going to be processed, at least in principle, within these models, and how the output, or sort of why the output looks the way it looks, again, at the principle level, because it's such a black box and you don't really understand the intricacies of each path through the model, is critical to being able to deliver like good product, at least today. Maybe GPT-5 changes that, I'm not sure, but yeah.
I don't think like the stronger the models, it definitely helps. I mean, I remember, the jump from straight GPT-3 to what eventually became GPT-4. And like everybody else on the planet, when we first got to play with it, we were like wowed. And then after a little while, we were like, wait a minute, it's making shit up. But the language capabilities are there, and it definitely, it like different prompting strategies for like the weaker model versus the stronger model, and what we can expect. You gain an intuition for like what's possible, and then there's all this work to sort of like round up the information you need to effectively like, drive the models. But you're not wrong. And I think the wave of startups is proof of this. Is, everybody's looking at this piece of technology and they're saying, well, with like a little bit of sweat, I can persuade the Oracle to give me useful results and turn it into a product. And that seems within reach for teams that previously were like, no, I need to hire like, 5 PhDs in order to even try doing this. Now it's like, I have an idea. I have an OpenAI API key. Okay, let's go. So definitely lower bar.
Yeah, I think we're going to see more and more of that as time goes forward. And I guess to take one step back, could you walk us through how you even landed in the AI space? Is that where you started?
Me personally, like,
yeah.
How did I land in the AI space? By accident? Really, I was not at all sort of in the AI space at all. I'm married to deep learning, machine learning, like, she's done computer vision and natural language processing. And she actually also works at GitHub on machine learning things for security applications. So I've like, just by virtue of being married to an expert in that field, I've like known a lot about it for years, but as an observer, like not an expert. And I'm still not an expert. Like, maybe I know more by osmosis, but not really. No, I ended up at GitHub. Like prior to GitHub, I was at Heroku, and I focused on sort of the human interfaces to data products. And I've always been sort of like a data guy, data visualization, data, like, stores and how to use them, how to apply them. And I ended up at GitHub because, so Jason Warner, who was SVP of engineering at Heroku, moved to be SVP of Eng at GitHub a couple years before I moved. And when I left Heroku, I caught up with Jason. He was just like, hey, I'm starting up this office of the CTO thing. That was GitHub Next at the time, because he had moved from being SVP Eng to being CTO.
Mm-hmm.
Come do this thing. And I was just like, well, okay, let's try it. And at the time it was like, tiny. There was nobody. It was like 4 or 5 people. And this dream of sort of booting up this function that does the risky things. And then a little while down the road from that, there was the whole sort of OpenAI and Microsoft partnership started to happen. And then Uga Damour was sort of like leading the charge on what was the early iterations of Copilot. And it was really through Copilot that I really even got into this world at all. And then since that, it's just, there's so obviously so many things to be done. There's more things to be done than there's time in the day. So accidentally I ended up in this world, and it was not on purpose. And now, like, it's convenient. I talk with my wife about stuff, and she's able to like explain it to me like I'm 5, and then
does ChatGPT do a better job, or does she do a better job?
She definitely does a better job, but I definitely use a lot of ChatGPT to like explain. Like here yesterday, I was fighting with I was trying to do some clustering, on embeddings, and trying to figure out a good way to sort of like assign like labels to sort of like areas of like a Latin space. Mm-hmm. And I was like looking at UMAP to like, reduce the dimensionality of that. And I had a whole long conversation with Chat about like, how will I apply it, and what do the different, parameters that I supply to UMAP, like, how many dimensions do I want to aim for, and why, and like, what do the like sort of like the minimum distance and the spread, like, how do they affect the way, and like, sort of trying to reach for the sort of like more subtle behaviors of like, it's reducing dimensionality, but it's trying to preserve like local structure and global structure and embedding space. That's great. I love that. And I think the best part about that is, unlike my wife, who has a lot of patience for me and my silly questions, Chat has infinite patience for me and my silly questions. And so I can do sort of that early conversation to like go from understanding nothing to understanding a little bit before I actually like, tap my wife on the shoulder and be like, can you help me please with my homework?
I think that I've said this, I think, a few times on the podcast, but to me, the main added value of ChatGPT is solving the blank slate problem, which is exactly what you said. Like, I'm not sure, like, once you have a structure for something that you're working on and you're trying to refine it to perfection, then a human still does a better job. But going from nothing to something with a basic structure that actually makes sense, like, that is done by ChatGPT at like 100 times, or I don't know, 100, but definitely like 10 times faster than if I had to do it myself. So to me, that's like the main superpower that's true for any sort of creative endeavor, whether it's writing code or writing a presentation, something like that. So I can totally relate to that. I guess one question that I have, given you touched upon this a bit, but given that it's very, very hard to evaluate LLMs, we've already spoken about this in the podcast, and I guess, spoiler alert, by the time this episode comes out, we'll already have posted another episode talking about evaluating LLMs. So that's something that's very concerning and sort of on people's minds. How do you evaluate the impact of these things that you're building, and how, like, what the impact is going to be on the developers' productivity, happiness?
I mean, there's a few different things, and I think the answer to that, it sort of depends on in what time frame and sort of in what there's like early evaluations. It's like we've built a little prototype. It's a shitty little prototype. Do we want to use it? Do we find that it gives us value as sort of like a first litmus test before we invest in and go? And then there's sort of like broadening circles of like who can access that we start to sort of like try it out on. So GitHub is a big organization with a few thousand people, and engineering is a few thousand people. And so I have a few thousand people that I can be like, hey, who wants to play around with this tool? And then, we get people use it, we get feedback. We also have GitHub stars, which is sort of, sort of high powered GitHub users that are also under NDA and are in Slack with us. And so we're able to like bring them sort of like early previews and be like, hey, try this out, use it. We have on our team like a researcher whose job it is to figure out how to qualify and quantify our bets and figure out frameworks for us to understand the impact of what we do. And it really varies by project. There isn't like a one size fits all thing. There are certain things that we do. We do, user statements up front where we really try to figure out how do we formulate a testable bet, like, which sounds like easy. It's just like, oh, like, it's like if the percentage of whatever improves by this much, then it's like succeeds. But no, very frequently we're starting out with something that's like experiential, and we need to find a way to sort of describe it in a fashion that we can actually test. And so the user statements sort of keep us honest early on, making sure that like we're thinking about it in a fashion that is testable. And then we go out and test it, and we'll test it on ourselves. We'll test it on other hubbers. We'll test it on stars. And if we need, we'll also go out and test it on people on the, like we'll commission studies and actually run them. But it really depends on the tool, like, how we quantified the impact of Copilot. There have been several studies by now, but one of them that I was directly involved in was about quantifying the time impacts of having Copilot, as developers with Copilot versus developers without Copilot. How fast can they complete a task, and can they even do they even reach completion of the task? And that required us, inventing like a task that we could test out on users. And that was hard because, like, for really simple things, Copilot will just one-shot it for you. And I didn't want that because it's like too easy. But on the other hand, you don't want to make something that's like synthetically, like, like invent some problem that's like synthetically difficult and like too esoteric. That's like not real. And so in the end, like, like what we ended up doing was fielding a study about like write an HTTP server with these specific behaviors. And so then it's like the internet and thus the models have seen everything about HTTP servers, but you can't just ask it to like write the thing for you that's going to produce these behaviors. It's like you need to actually like stitch together, like, here's the task. It needs to return 404 if like the file on disk is not there. And if the file is there, then like, read the file and like, send the contents of the file. And if whatever, like there was like 10 bullet points of things that you needed to like accomplish. And that was great because, developers could still look, they could read as much as they wanted on the internet about HTTP, and Copilot would help them if they'd actually start building like the right structure, but they would need to do the real thing of programming, which is start building in a certain direction, and then Copilot could help them. And there we saw like a huge uplift in like developer productivity. So that's an example of like something to do, but it changes from project to project and depending on what we want to prove. If we want to prove that there's like a benefit to how developers feel while using Copilot, then that's a very different study, right? And it's not any less meaningful than like how much time it saves. So there's some combination of like, like actual testing on users and doing these quantifiable things, and also like doing surveys or like testing on users, but asking more qualitative questions about like, how it makes you feel or how it sort of keeps you focused and in the zone. There's a lot of different sort of approaches, and there isn't one size fits all answer to that.
So that's a really great answer. And in a sense, I think that you're lucky to be working in an organization where there are so many people and you have access to so many sort of alpha testers, if you will. I'm curious, like from your experience now, if someone is listening and they're in a smaller organization, which is probably most people, right? how do they how should they go about testing similar products or similar capabilities?
I mean, I don't know that I'm going to have an answer to that hasn't been said like a billion times before in like a trillion posts about how to achieve product market fit in your SaaS startup, like, because that's kind of what it is. It's like, what do you need to do? You need to go find people to use your thing, and then you need to watch them using your thing, and you need to shut up while they're using your thing, and just watch them. It's a very humbling experience. But like, how do you go about getting people to like use your thing? Like, it really depends on what your thing is. How do you watch them using your thing? Really depends on what your thing is. And then I'd say maybe the more relevant thing for sort of AI sort of focused things is crafting some kind of like evaluation harness. Like, let's say you've gotten people to use your thing. How can you passively monitor like their usage of the thing and know if it's good, it's bad? Like, or you're rolling out a change. Does it make things better or does it make things worse? Sometimes it's really hard to tell. So I'll share the example from Copilot is like, what I was saying earlier, there's like acceptance rate. That's sort of like the top line metric. How often do people accept suggestions from Copilot? Mm-hmm. And then you're like, okay, is the acceptance rate about language, right? Like, is the model like, like hiding inside this total number, like, like 40% acceptance rate or 50% acceptance rate or whatever. Does it vary by language? Like, the models have seen a lot more Python than they've seen Haskell. And so chances are the models are delivering better suggestions in Python than they are in Haskell. And so now I have like, charts by language. Okay. Like acceptance rate by language. Cool. But wait, is it about latency? Like, I have inference running in US East and maybe in Europe West. What if you're in Asia? Is like the acceptance rate lower in Asia? Like, is that dragging down my overall acceptance rate? Like, all right. And so now I've got like, acceptance rate by language, by geography, right? And like, you can keep exploding like the number of charts, like, ad nauseum. And so the hard part is sort of like choosing like what are the right things that you actually want to like look at, and then tracking them. Like I said, we track acceptance rates at the moment of acceptance, but then also a lot of times it's not bad for people to accept and then immediately like mutate the thing. In some ways that's even a signal of like more success. Like, yeah, okay, maybe it didn't outright solve the problem, but it was valuable enough that the user was like, I'm going to take that and I'm going to like tailor it a little bit. They were willing to invest more energy than just hitting the tab key, right? So now, like, again, I have 1 trillion charts. Which ones do I actually like pay attention to? Building that out is hard, like, and sort of like, tracking that. But even like before you roll it out and test on your users, we had an offline evaluation harness, which also was a lot of effort to build. We took projects that had like, like a good test suite on GitHub, like, public projects with test suites, where we could identify the subject under test. Well, it's like, here's a function and here's 5 tests for that function. Great. We're going to take the function, we're going to blank it out, like, blank out the body of the function, regenerate using Copilot, and then run the project's test suite at scale for like many repositories across GitHub. And then any one run doesn't mean anything. Like, it's like I use Copilot to regenerate like this thing, like the test suite passes this time and it fails the next time and it passes the time after that. Doesn't mean anything. But at scale, that maybe gives me like a smoke test to see, like, is code generation improving or getting worse over time before it even reaches users. So, like, that's very effortful. even a small organization can do this, but it sort of depends on where you are in like the startup life cycle, to like reach people in order to see them or to observe them passively by sort of like looking at metrics and then like which metrics are you tracking, or to set up these sort of like smoke tests or evaluation suites that run offline before it even reaches users in order to get a sense for like, are the changes that we're making. So those are sort of the three maybe categories. And then like when you're really tiny, it's always coming down to like, well, which one am I going to invest in this week? Because there's only this week. Next week is a different question.
Sure enough. I think that my takeaway from what you just said is that you can sort of break it down into three parts. And I like that the first part is basically an AI product is first and foremost a product. And so all of the like product wisdom applies there as well. And it's nice to have, like, I think we spend maybe this is a controversial take, but I think we probably spend a lot more time talking about like synthetic test benchmarks and who's better at beating them, or who's better than GPT-4 at some narrow benchmark that someone invented, and not enough time on like, is this actually bringing value to people in real world context? But if I split it down into three, then the first part is this like product UX testing. The second part is sort of like an equivalent to an integration test, which is you want to see like what are the metrics that you're like hitting with your users, and that's going to be product specific. Like you need to understand your product and how users are going to use that, and then you can break things down and actually make sense of whether or not like is accepting a code suggestion a good or a bad thing, right? So you need to understand the product context, but then you define something that theoretically could be like collected, measured, and put on a graph, and you can see if you're headed in the right direction. And then you could say the last thing is like the unit test equivalent for data. So you have test suites, you run them when a version is ready, and you make sure that it's not doing stupid things like saying that dogs are cats, or suggesting Haskell for Python users or something like that. Yeah.
Except the test suites because of the non-determinism, it's like they're only valuable at scale. Like you can't do like just a little bit and expect it to like be meaningful. It's only meaningful when you do it really big, or like enough times. So yeah, I think. Sorry, go ahead. It's like I'm gonna save my spicy takes for later.
Okay, fair enough. So I guess one other area that I wanted to sort of hear your thoughts on is, it seems like today, due to how sort of the current version of AI came to prominence, which is ChatGPT, right? Like I'm sure that at some point in the future, people are going to claim that ChatGPT wasn't the definitive moment and things like that. And it was very gradual. But I remember the week it came out, I had a flight to San Francisco, and basically the entire world was only talking about one thing, and that was it. So I think that because of the fact that ChatGPT was chat, that is how sort of a lot of the interfaces have shaped up or shaped into in the last year or so. I'm curious what your thoughts are on that, and how, if you think that that's how interfaces are going to look also moving forward.
Absolutely not. I hate chat. Chat sucks. I mean, no, it doesn't suck. It's great, but for what? It's like right now. I mean, humans are lazy. We always want to choose the like path of least resistance, and chat is the path of least resistance when it comes to building AI things, because the models naturally are good at chat. That's what they're like, sort of they naturally want to do, right? Is you show them text, they give you back more text, right? It's a lot harder to figure out how to generate code, like in situ, in the editor, in a fashion. There's all these little problems that you don't think about. It's just like, like when do I stop? Like when the code suggestions are coming back, like when do I stop taking the suggestion? How do I insert it into the code without breaking semantically like other things? How do I collect the context from the code in a fashion that is semantically sound. Like one of the things we did with early Copilot, this is less of a problem now that context windows are bigger, but like when context windows are smaller, which I think is important once again, because like, yeah, okay, the biggest models have bigger context windows, but now we have the open source models that are coming up underneath. They're smaller models, right? And they have smaller context windows. And so it's not true that like we only like, you know, like now we live in the future and we have 128K tokens. No, we have 1 million tokens. No, we have whatever. Like, no, we're always going to have these smaller models, and we're going to want to use them in more situations. And so we still need to retain the ability to like work with like smaller window. So in the beginning with Copilot, we actually sort of like, you know, take the file that you're in, and then we would semantically restructure, like hoist chunks, because if your insertion point is right here, your cursor is right here, and up here is referencing a function that's down here, right? If we just take all this as context, then we're missing this guy, which might be very important context, and it's being referenced from in here. So like, okay, we need to hoist this function up here, but in a fashion that is still semantically valid, because if you show semantically invalid code to the model, you're far more likely to get garbage back. And so like hidden effort in the production of Copilot, learning how to restructure like files so that they remain semantically sound, so that when we put it into the context, like the cursor is at the bottom of the context, right? It's like entirely invisible to the user, right? But like if you want to use smaller context windows, that's the kind of shit you need to do in order to like increase the reliability of like what comes back. So yeah, so there's a lot of things that are hard to do not in chat. Chat is easy. Whatever comes back, I just print to the user, right? But so when I say that it's lazy or that it's sort of like it's bad, I don't actually mean it's bad. I love using chat for exactly the stuff that we talked about earlier. It's like I want to talk about a topic. I want to explore. I don't actually want to do when I'm using chat. And there are improvements to like chat. Like now with like Copilot Chat, you actually have sort of the chat sidebar in VS Code, and it's gained some sort of like UX affordances for like moving context into chat and moving results out of chat back into your code. Sure, that's going to get better. But I think that we're still in the early days of AI, where we're just sort of like bolting chat onto the side of everything that moves, instead of actually figuring out what it wants to be. And I think the future of AI is a lot of things that don't look or even feel like AI. It's just like, you know, you walk into your kitchen and everything's all set up for you. Like you wanted to cut yourself a salad and you walk into the kitchen and there's your cutting board and your tomatoes and your cucumbers and they're just ready for you, right? And that's what AI is going to feel like. It's not going to feel like Clippy showing up like, it looks like you're trying to cut a salad, like, you know, like trying to like help you in that moment, which is what chat feels like today. So I don't think chat is going to go away. I think it has a very important place as one kind of AI tool, but I think the kinds of AI experiences are going to feel more invisible. Like, you know, right now it's just it's like the Zoolander meme, so hot right now, that the AI thing, like, you know, but in the future, it'll just be like another piece of technology. Like when was the last time you were like, Windows, man, fucking Windows, I moved them around on my screen and they're amazing. No, it's like you take it for granted. And I think AI is going to sort of eventually be threaded through every other experience as sort of that sort of thing, and not going to be chat. It's not going to be anyone. We'll find these sort of places where it fits in, and we'll find these basic mechanisms too, these basic sort of these UX patterns for how to like integrate AI that people are going to learn, and are going to be familiar to everybody. Like, you know, like pull to refresh on your phone. It didn't exist when phones started to come out. It took some time to discover that was like, that's the way to like refresh on a phone instead of having a button that I tap, right? Because everybody intuitively knows that more content is further up on the phone. If I want to see more, I want to pull down and see more further up. And then once that was invented, everybody was like, oh yeah, obviously that's obviously how it's going to be. So we're still in that phase of like figuring out what's like the pull to refresh things for AI. that everybody's gonna gonna know in the future.
That's interesting. I remember the year the iPhone came out. It seemed like at least I'm living in Israel, so and I was pretty young then. I remember one kid in school, like his dad flew to the States and brought back an iPhone, and I remember that we were most excited about the fact that you could like pinch to zoom. But I
Yeah.
remember that after like a bit of time went by, there were a lot of really stupid apps. But in hindsight, the goal of all those stupid apps was to like test the boundaries of this new medium. I remember you had like a lighter thing where you do like shake your phone and then the lighter would light up on the screen. And so it was things that are like stupid now, but at the time people were figuring out that you now have an accelerometer within your phone. Like, what did you do with that? And now you have, I don't know, whatever, Pokemon Go, stuff like that are much more cutting edge, but you had to have the stupid lighter thing to build them. And so I think that we're probably undergoing a lot of that with AI right now. Like there's a lot of applications that don't make a lot of sense, but I think it's like people testing out the medium, and that means that we'll probably converge on the things that do make sense in the next few years. So I tend to agree with that. One other thing that I think you are very well positioned to answer, and maybe much more so than other people, is you mentioned that the first step, right, is testing with the couple thousand engineers that are in GitHub, which is already a pretty big scale. But what happens the next step, right? Like, I don't know if this is something that you can share, but like how many GitHub Copilot users there are right now, if you know, and how do you, like, what changes when you stop working on this as a prototype and then it moves into the realm of actually needing to be a product that meets scale?
First of all, I don't know, like regarding numbers or whatever, and I don't know even if I did know if I could share it. So
No worries.
Just gonna move right past that. But I think I'll hijack the question and say it depends on. I mean, different businesses do innovation. I hate the word, but like that's kind of like that's what Next is. It's the innovation team. If somebody like forced me into a suit and tie and told me to go speak at like a business conference, and I'd had to describe Next, I'd be like, it's the innovation team, because that's what everybody will understand.
Mm-hmm.
And so I think what's hiding inside your question is, what's the relationship between the innovation function of a business and the mainline? And that's different at different companies. Google famously has 20% time. They've attempted to sort of peanut butter the innovation everywhere, across everyone, right? And say like innovation can come from anyone. And so everyone spend 1 day a week working on things that could be innovative so that we have maximum chance of discovering like new things. Whether or not it actually works that way in practice, I don't know. Like, need to ask some hubbers whether or not that's like real or if it's bullshit. Not hubbers, sorry, Googlers. In our case, like it's the exact opposite of that. They've decided to sort of like stick the risky innovation in like a leak-proof container outside of engineering, so that the like if something blows up, like the blast radius isn't going to affect engineering so much, and that our job is that by the time something like sort of crosses the chasm, I saw your Jeffrey Moore reference, into engineering, like that it's well qualified, that like engineering has confidence that like this is really a bet worth making. But once it's in their hands, unintuitively, it really matters that it's not our job to say how to roll out, how to check. I just triggered the Apple thing.
It's fine.
How do I turn off the reactions? There we go. Now I can do this and nothing will happen. Not because we couldn't have a positive impact on that, but because if the innovation team is like doing stuff all the time, and people in engineering are like working on, like reliability, and we have like incidents and fires and keeping the lights on and improvements, right? Their job is still to improve the product, but just not in like big jumps. It's like today we're here and tomorrow we can be one chessboard square like in this direction or in that direction, That's the job of engineering. I don't want them to feel like we're constantly like throwing things at them to do. Like, that's not a healthy relationship between an innovation function and engineering. I want them to feel like every time I show up with something, they're like, Santa Claus is here with presents for us. And here's things that like we never would have done if it wasn't for them, like chopping a trail through the jungle and giving us a map. So how to do that last phase? First of all, like it's not really our job, like, and so we don't do that kind of sort of scalable, durable, like in market, stuff. But also, it's wrong for us to be too involved in that, because I want engineering to also feel like when they ship the product, it's their product, and they have the win of taking that product. And it might not look at all like the thing that we made. So long as we gave them the confidence to go off and do that thing, that's success. And it needs to be their decision what product they want to ship. Our prototype, if they want to take it and turn it into a product, great. If they want to take it and be like, that's cute, and now we're going to do it for real, but we're going to rewrite it from scratch, also great. But it needs to be their call. So not exactly the question that you asked, but I think that that's something that's really important to understand about sort of like how prototypes graduate into products. It's not just like, here's the prototype, now draw the rest of the fucking owl. Like, no.
I mean, it could work like that, but it sounds like a recipe for, I don't know, disaster, but it's definitely dangerous. I think that, so maybe taking a step back and asking some higher level questions, what are your thoughts on sort of what's currently the hardest unsolved problem in the ML or AI space?
I definitely think sort of I don't know, you know what? I spend a lot of my time thinking about sort of the user experience things. Like everybody's sort of like has this fascination with chat and chat interfaces. How do we reach for more than that? How do we reach for more than the sort of like back and forth modality? Right now, I'd say a lot of Next's efforts center on piercing the suggestion ceiling, like getting the model to suggest this much stuff, relatively easy. Like now. But like, what if I want to synthesize an entire project or an entire pull request? It's like playing blackjack. It's like, you very quickly like bust past 21 and then you get back hot garbage from the model. And Copilot was a success because it achieved a level of reliability. And generally speaking, with the models and the non-determinism, success is achieving reliability. Like I've found some set of things that makes the model consistently return something useful. My favorite analogy here is literally engines. We call ourselves engineers, but like once upon a time that involved actually building engines. Like when you get into a car and you like turn the switch and that, like a controlled explosion is happening 1 meter in front of your nose. And what is engineering? Engineering is reducing the incidence of death to the driver from the engine, like, and making it so that like other drivers are actually the greater risk. Like the number one reason why I die is not the engine exploding in my face; it's another car crashing. That's it. So here it's like, well, what are the prompt crafting techniques and the filtering techniques and the whatever techniques that we use to reduce the incidence of this blowing up in my face and returning hot garbage. And it's not.
It's a really nice way to frame it.
Yeah, it's like every day we get into our cars and I don't think about the engine blowing up in my face because engineers reduced the incidence of that to a level that was acceptable. Like it doesn't never happen, but it almost never happens. I expect it to not happen. So building AI products is about sort of like driving down the instances of it returning like crap. Um, and as soon as you start asking it for more, you're driving up the incidence of like the model returning crap significantly. It like starts feeling like a slot machine, and a slot machine is not a product, right? Like, I think that's also part of what's like fueling like the boom in AI startups, is that it's really easy to take like take an OpenAI PI key and build a little demo, and it works like 20% of the time. But in that 20%, it's super impressive, right?
Yes.
But then going from like 20% reliability to like 80% reliability that's where the bodies are buried. And it's not as simple as like, well, I'm just gonna prompt craft hard enough and it'll be okay. Like, no, it's hard. So achieving like getting past, breaking through that suggestion ceiling requires like figuring out ways to make the process of generation steerable. And it's not like, right, I have like a one-shot conversation with a model, and I don't have a way to like steer it in the middle. So it really means like, how do I break it down into like multiple steps? And that's hard. Like, there's a lot of stuff that we're working on there. Like, one of the things that we're working on is like Copilot workspaces, where we sort of break down this process into like, it's like I query my code base about the behavior of a certain system, like how does authentication work? And then it comes back and it's just like, well, like, in this web app, like, if the user's unauthenticated, show them the login screen. And then when they submit the form, like take the username and the password, hash the password, compare it to what's in the database. If it matches, great, like send them to where they're supposed to go. If not, show like an error message in red text. That's great. They're like, okay, I've just described, like AI created a spec of like how this subsystem works. And then instead of immediately jumping to say like, what I want to do is I want to add a forgot password flow. Something. But if I just like prompt the model, like, add a forgot password flow to the thing, it's likely to go wrong. So we query and then we produce the spec, and then I let the user edit the spec. And I say like, no, actually, here's where the spec is different. And also here's new things that I want to happen. And then we'll use that diff of like, the spec as prompt to the next phase, where we produce a plan, right? How do we go from like what it is today to what it is that we want to be? And then that plan is editable too, because maybe the model didn't catch some edge case or didn't think of some things. It's like, I need to like create another moment where the user can have their hand on the steering wheel and like alter it. So I can edit the plan to like add the edge case and to add the whatever. And then when I submit the plan, that's when it actually generates the code. So I've got this like multi-stage process, each one of which represents multiple round trips to the model. Like in the first stage, like we're doing one round trip to figure out which files to include as context, what's relevant to this query, like, and then we actually make the query and get back the plan. So that sort of like approach overall is hard, and I think is sort of like on the cutting edge of like, how do we get away from chat and towards something that is iterative, but is an actual interface, not just like I have a conversation with a robot and then I have to take like my learnings from the conversation and figure out how to apply them. Like, how do I actually build a more direct interface for manipulating this thing? But that isn't just, like pulling the handle on a slot machine. And that's not the only kind of thing that we're working on in this general direction. It is like getting away from chat and getting towards like interfaces that weave AI, or sort of, I call this AI native, like, in the same way that like pull to refresh is like a touchscreen native gesture that didn't exist in the beginning. Like, how do we reach for these AI native things throughout the development workflow and make it so that it doesn't suck? Like, all the AI haters are like, oh, this is producing garbage. You're like, yeah, of course, if you start with a blank file and you give it half a prompt, it's going to produce garbage because it doesn't know what you want. And so, like, how do we go from AI being like the garbage spewing machine to being a useful tool? It's this kind of effort to figure out how to like reduce the incidence of the engine blowing up in the face.
I love that. First, I really like the analogy. I'll say that the sort of 20% to whatever 80 or 99% to me is like sort of the increasing RPM, right? Like you risk the chance of things going wrong if the engine needs to work faster, or in the AI case, like increasing the output size or giving it less to work with or something like that. And then the engineering efforts there are, I mean, in the engine case, that's like, adding special lubricants so that there's less friction and things like that. And to me, what you said is like, for the first example that you gave was the like changing of the code within the file so that the context makes sense. And you now gave a bunch of additional examples. I think this is going to be super valuable to people who are thinking about this problems. But if you break down the process, like this is my rephrasing what you're saying, if you break down the process into steps that make sense logically, and then you introduce AI into each one of them in a way that actually makes sense, then you could get a result that's much more cohesive, requires less of the user, and then sort of you can more easily get from the 20% of the whatever 99% of actually being a product that works for everyone. So that's awesome. That also in a sense answers my previous question about like meeting scale. So that was great. I know we're almost at time, so I'll end up with the last thing, which is recommendations for the audience. Anything you like, doesn't have to be related to data science or machine
learning. I'll give a shout out for a product that I am really enjoying using. I guess it's two products. It's sort of like they do go hand in hand. So I know everybody. Okay, so controversial hot take. I know everybody loves Python for data science things, and as a sort of Python expat myself, who transitioned into sort of like front end and JavaScript and whatever, like JavaScript and TypeScript is actually lovely, and especially with the rise of WASM, it's like I think that there's a future for data things being done in JavaScript or TypeScript, and that could displace Python as sort of like the language of choice for that. So I could see that being a future, or maybe it doesn't matter. Maybe it's like in the end, Python will get compiled to WASM and then it runs wherever WASM does, which is everywhere. That together with Deno, which is like a newer JavaScript runtime, a sort of a replacement for Node, but like modern, and it doesn't have sort of like NPM in this install step. It's like instead of importing from a package that I had to previously install, I import from a URL. And so I don't have like an install step. Like when I run it, it just pulls things down. And so nice. I really love Deno for a lot of things. It's like sort of like just a nicer JavaScript, like server-side JavaScript environment. And I find myself using it for a lot of things just because it's such a nice environment to work in. So shout out to Deno. And if you miss pandas in the Node world, there's something called Arquero, 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 which means archer in Spanish. And it's pandas, but in JavaScript, and it's nice. And like, because JavaScript works in more environments, it's like, do I want something like pandas, but in this world? So that's my technology hot take. Oh, and Supabase. I'm using Supabase a lot at work, which is really nice. And their edge functions are powered by Deno, but just having like sort of like Postgres database as a service with like real-time notifications and things like that. But they also support PG Vector, so I'm using it as like an embeddings database as well. That's just a really nice, really like well-crafted environment. As somebody who's worked on Postgres data products previously in my life, it's like, this is a nice one. I like it. I like using it a lot.
I'm familiar with Supabase, but I did not know the Deno thing, so I'm going to check that out. That sounds really cool. And the Arquero. Pandas is good everywhere, so if there's a JavaScript version, that sounds awesome.
I mean, Pandas is good is a spicy statement of its own, because it's like, if you spend whatever, I did a huge project with Pandas once upon a time, and then 3 minutes after I was done using it, I forgot how to like use data frames because it's like impossible to keep in my head. It just leaks out immediately. So I can't say whether or not Arquero is better, or whether like, it's like inherently just like the whole like paradigm of data frames and sort of columnar operations being difficult to keep in my head is just true in general, or if it's like Pandas specific, like, but yeah, I don't know. Now I get to stay in TypeScript land always, and it's great.
So wait, so you write all the ML in TypeScript? Like all the work that you're doing is, I guess you said it's not classic ML, right? But
No, because
still.
I mean, like, yeah, there is model training that happens generally in Python because there's just
It
a
is.
more mature tooling ecosystem around that.
Yeah.
I think a lot of that relationship also comes from sort of like historically, it's like, well, I need to install CUDA and I need to install this. And then there's like Python Blast that like links up with that and allows me to like, whatever. All that stuff is sort of like, brick on top of brick, which makes it easier to like start. But like web GPU is becoming a thing. Eventually it'll just be easier in a sort of platform agnostic way to talk to a GPU to do GPU based computation from JavaScript because it's running inside this like environment. And then like it might not be JavaScript, it might be Python that you compile to WASM, but it's still using web GPU to talk to the GPU as sort of the intermediate layer. Like my prediction there is that in the future it might move in that direction because it's just going to be easier than like fighting with like installing these tools. And what happens if like now I'm running on an ARM server that's got some GPUs attached to it, and like I don't know, like that stuff is painful. Like, nobody likes to spend time on it. So eventually the web wins at everything. It just depends on the time scale.
Yeah, that's interesting. That's interesting that might also change the dynamics in the GPU wars that are going on right now. So that's going to be an interesting time to be living through.
Yeah, I mean, like if it makes, like right now everybody's just like, I need NVIDIA GPUs, but like, what happens when there's like an intermediate layer that makes it so I don't care if underneath it's AMD or NVIDIA, or I don't know, some company will come up and be like, I've made something that's not a GPU, but effectively does the same thing that a GPU would do, underneath, and I don't need to like think about it. My code just works for it. It's not like I need to translate from like the NVIDIA specific libraries to some other library. Like, no, like, that's coming eventually.
I wonder if maybe Jensen is listening, so now he knows to watch out. Yeah, Idan, thank you so much for joining me today. I think a lot of people are going to learn a ton from all of the stuff that you shared with us today. So thank you so much for your time.
My pleasure. Thank you so much for having me, and shout out, check out githubnext.com to see like what our team is up to and projects. And we do a lot of like sharing of nerdery there. And yeah, thank you so much. This has been a blast.
Awesome. So until next time, and thank you everyone who joined and listened. See you next time as well. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.